Thank you. Yes, if you would humor me by some of you in the back just moving up forward, because I want you to be able to see the slides, and I also would like the chance to have a conversation toward the end in a little more intimate way. So feel free, but not obligated, to move closer if you so choose. Now, the setup here is a little awkward. I'm used to having the laptop up with me, and that's not possible here. So for me to make sure I know what you're seeing, I'm going to have to turn around frequently to kind of make sure I'm on sync with what's on the screen there. So bear with me in that regard. But we are going to be talking about our incredible universe, which I believe is also inspiring. And I hope you've already had your appetites whetted by this program we just saw, which was quite interesting to me as well. That's me with a model of the Hubble Space Telescope, and behind me is a Hubble image of a beautiful galaxy, the Whirlpool, which we've been able to see such detail in images like this because of our telescopes. But that hasn't always been me. That's really not the me that I grew up with. The me I grew up with is this me. I grew up with cattle in the Ozarks of Arkansas. I was raised by wolves. No, just kidding. But that's me with several layers of clothing in a cold January day in the Ozarks feeding cattle. I grew up in the country, and I didn't know any scientists, and my parents weren't even able to go to college. So I didn't have that kind of scientist example right before me my whole life, but I did get a lot of exposure to nature, and I think that's what fertilized in me a love for science, which is that I love nature. I love being outdoors. I loved just wandering the streams and valleys and hills without constraints. I really enjoyed that part of growing up in a peaceful rural area. I love animals. And we could see the night sky on clear nights quite easily then, and so it made it more natural to look up and to imagine where we fit into this universe and to try to imagine what it would be like to go and visit some of these other places. It was also the period of time when I was growing up when NASA was sending these spacecraft to other planets in our solar system and sending back images of other planets and their moons, the Voyager spacecraft, the Pioneers, you remember that? And Carl Sagan was at the height of his Cosmos program, and I was very inspired by all of this. So I think all of that blended together to make me into someone who wanted to study nature and even do so professionally. So what can we see professionally now? We can see great beauty with our telescopes. This is an image of a cluster of stars called Omega Centauri. And it is an image that was taken by the newest camera on the Hubble Space Telescope. The Hubble Telescope is a satellite in orbit around the Earth, and it sends us beautiful images like this. This was just a calibration image of the new camera, but it was so spectacular that it's become popular in the public as well. And I like this image because it shows to me an example of the beauty of what's in space that we can tease out when we have technology to do so. And even the colors here are quite spectacular. When I show this image, I often ask people what colors they see. So I'd like to ask you to tell me what colors you see here. Got it? Okay, red, blue. Okay, which ones are the hottest stars? Trick question. All right, yes, the blue ones, right. The outer atmospheres of the reddish stars are actually cooler than the outer atmospheres of the bluish stars, but they're all hot. They're stars, right? And what else do you notice about these stars when you look at the array of them? You notice anything? They're different colors. What else? Right? They're different. They appear to be different sizes, or rather different brightnesses. Now in astronomy, it's hard to know when you see something that's brighter than something else. You don't know if it's intrinsically brighter or if it's just closer, right, that makes it look brighter. In this case, this is all part of the core of a cluster of stars, so they're generally more or less the same distance from us. So the brighter stars that look brighter actually are brighter. So the point of this is to let you know that just by looking at this cluster with a good telescope, you can tell that stars are not all the same. In fact, those of you theologians should be able to tell at once that there is a verse in the New Testament that says star differs from star in splendor. Anybody know what that is? Very good. All right, you get the brownie points. Okay. Now the other thing you'll notice here is that we can differentiate star from star. You see, if we were to look at this cluster with a telescope on the ground, you just see one kind of blurred image of all the light coming together, but with a telescope in space, we get above the blurring effects of the atmosphere, and we can differentiate star from star. It doesn't all blend together. We get high angular resolution of the images, and that's one of the benefits of going onto a high mountain, or even better, up above the clouds into space to do astronomy. So what does astronomy do for us? Well, it inspires us. Kant said that two things continued to fill his mind with ever-increasing awe and admiration the more he reflected on them. And those two things were the starry heavens above him and the moral law within him. And I think that's written on his tombstone and translated roughly here. So I think this is quite an interesting observation, because it's still the case now that in popular conversation, the two things that generally grab people's imaginations the most are not only the starry heavens and cosmology and where we came from, but science in general, even on the small scale. What are we discovering? What does it tell us about ourselves? And then this moral law issue, where does that come from? C.S. Lewis wondered that. It actually helped bring him to become a person of faith, as he wondered why everyone has a sense of justice within them. And who gets to decide? You know, there's a constant discussion in different cultures. What's right and wrong? Who gets to decide what's right and wrong? Who gets to set the rules? But we all have a sense that there's some sense of right and wrong. Where does that come from? So these things inspired Kant. And of course, the third thing that inspires everyone in this country, at least, is to wonder about the lives of movie stars. But he didn't think of that. And I don't know if I can mention a reformer in this Catholic crowd, but Calvin said that astronomy is not only pleasant, but is also useful to be known, and that he could not deny that this art unfolds the unfathomable wisdom, or the admirable wisdom of God. So, and you think about what astronomy was in his era, it was what we might call primitive, but he was already realizing that astronomy is something that could be intimately related to theology or worship. All right, so I'd like you to really sense, if you haven't already, something that we don't get to discuss much in scientific papers, but that the universe is in fact beautiful. There's some connection between what actually is out there and what we process in our minds that give us a sense of beauty. Here, for example, is the region of the sky known as Orion, correct? This is an image taken with a telescope on the ground. Telescopes have different capabilities. So telescopes like the Hubble Space Telescope are wonderful for getting sharp images over small fields of view, but Hubble can't see big, broad fields of view. This is a nice image from the ground. It gives you a nice, broad field of view of the region of Orion. But when we look at part of it with the Hubble Telescope, and I'm going to see, I guess I don't have a, oh, I do have a pointer. In this little green boxed area, so you recognize Orion's belt and sword. Here's that bright star Betelgeuse and Rigel down here. But even if you look with binoculars or a backyard telescope at the stars in Orion, you see some fuzziness around some of these stars, and astronomers call anything fuzzy a nebula. So anywhere in this green box in particular, you see fuzziness that's quite interesting. Let's zoom into this region right here, which looks fuzzy in the image, but we're going to zoom in with the Hubble telescope and see what you would see just in that small field of view. And that's what you see when you zoom in on that little fuzzy region with the Hubble telescope. This is the Orion Nebula, and it is bright, it is colorful, It is bright and colorful because it's full of gas, and the gas is being ionized by the bright radiation from young stars that have just formed out of some of the gas in this region. One thing we've learned over the last century is that star formation is an ongoing, very active process. Stars coalesce out of collapsing clumps of gas and dust in these interstellar clouds. And if there's enough mass that's collapsing under its own gravitational weight, the pressure in the core of these clumps will be high enough to start a reaction called fusion, that the hydrogen, and most of the gas is hydrogen atoms will fuse together into helium atoms. This whole reaction releases photons of light. The light eventually escapes from the surface of this new star, and we can see it as starlight, but some of that light photons are strong enough to actually hit atoms of surrounding gas, ionize them, which means temporarily separating the electrons from the protons, and when those atoms recover, they emit colorful light. So when astronomers see a nebula like this, we say not only that it's beautiful, but we say, aha, this is a sign that massive stars have recently formed in these clouds. Now, for my own research, I looked at this region not with telescopes that see visible light like Hubble, but I looked at it with radio telescopes where you can see some of the dark gas behind this lit up region where the stars are still forming, but they haven't turned on yet. So we can see what we call protostars, and we can see them heating up, but we can't see any light from them yet, at least in the visible, because they haven't turned on yet. And there's more beauty. Here's another one of these interstellar nebulae known as part of the Horsehead Nebula, but it's such a small part of it that you won't be able to see a monkey head unless you really imagine it. But you will notice that in a lot of these regions you see these pillar-like formations. And what happens is when a massive star forms, it sends out its powerful light and its winds, and they tend to chisel out regions in the surrounding gas. The denser regions stay on the longest, so they retain their presence in terms of looking like a pillar, and the less dense regions of gas get blown away more easily. So you get these kind of pillared-like structures often in star-forming regions. Here's a just gorgeous image of the Horsehead Nebula taken in infrared light with Hubble. But you see this majestic architecture there. To me, it looks like a dragon's head. And these clouds of gas and dust fill what we call galaxies. Galaxies are collections of gas, dust, stars, in many cases hundreds of billions of stars. And often over time they will take on, through their rotational properties, these spiral shapes where many stars are concentrated in the core, and then you get these spiral arms outside. There's a halo in the middle. This one, I think, I took it kind of at random out of the Hubble Telescope archive, but I think it's a really nice example of a spiral galaxy. We think our own Milky Way looks something like this if we could get it outside to take a picture of it. But it has this bulge in the center with a lot of stars, all the starlights kind of blending together. And then it has these spiral arms. And if you look carefully, you'll see some background galaxies here as well. It's such a striking image. I think this is just beautiful, and so did those who named it in the first place. They were so moved by the beauty of this that they named it poetically NGC 1309. Astronomers do need poets to help us out. Okay, so how do you feel when you see something like this? If you were at the morning prayer service, we sang this, and so I won't put us through that exercise right now, but some feel a great sense of praise, even worship for God. Here's the famous words, "O Lord, my God, when I in awesome wonder consider all the worlds thy hands have made. I see the stars, I hear the rolling thunder, thy power throughout the universe displayed. Then sings my soul, my Savior God, to thee, how great thou art, how great thou art." That's many times the response that people have when they look at the heavens. But it's not the only response. I mean, there is no law for how you should respond when you learn more and more about the heavens. And it's equally valid, or even maybe you might go from one to the other and back and forth, as Steven Weinberg, the physicist, says that, you know, the more the universe seems comprehensible through our physics and our investigations, to him, the more it seems pointless. All right, so what you philosophically infer is not necessarily dictated by the data alone. All right, so this is an example of a telescope. The Hubble Telescope is one space telescope. There's quite an armada of telescopes in space now, and also in the deserts and on mountaintops. Generally, we like to put them in places that are dry and that are far away from interference and light pollution. The Hubble Telescope was this concept of putting it on a satellite to get it above the clouds. As you can see below, that's the surface of the Earth. The telescope doesn't go very far. It's in low Earth orbit, so it doesn't actually whiz around to other planets and things. It's circling the Earth every 90 minutes, and it's been doing so for 25 years. So we're now celebrating Hubble's 25th birthday. Can you believe that? It is the advance of technology that's enabled us to see the things that we now see in space. And so here's an example of how technology and its advancement has helped us advance our understanding. And that, I would posit, has helped advance theology and theological reflection. So these things have an interesting interplay. If you look on the bottom axis here, this is a timeline from the centuries, from the 1600s, 1700s, 1800s, 1900s through the 20th century. And on this axis, what we're seeing is the sensitivity improvement of telescopes over what you could see with just your bare eyes. All right, so this would be 100 times better and so forth and so on. This is a logarithmic scale, so every tick mark here is 10 times better than the one below it in terms of sensitivity. So you see, starting with Galileo's telescope back 4 centuries ago, he was able to discern these moons around Jupiter. But since then, with better eyepieces and better telescopes, this graph is showing this enormous increase in sensitivity over what we could see with our naked eye, until the point that photography was attached to astronomy, so we could record light for longer periods than the eye could just soak it in by staring through a telescope. And then electronic recording pushed us much beyond that in terms of sensitivity. And then the idea of going to space, the Hubble Telescope, brought us orders of magnitude better sensitivity. And over the years, we have improved the Hubble Telescope time and time again by sending astronauts to install new and better instruments. The last time we did this was in 2009 with servicing mission 4, SM4, which was the 5th servicing mission, so you can ask me sometime how that came about. And it took us off the chart here. So we've been doing great things in astronomy because of the improvements in technology, and this improvement in technology is continuing. Here's the astronauts that did the last servicing mission for Hubble. We can't do this anymore because we don't have the space shuttle operating anymore, so what they did had to be done as good as possible to keep Hubble as operating as good as it can. And they did. They did a fabulous job of putting in new instruments, repairing instruments that were already on board, and putting in new batteries and gyroscopes. So, and they did this on orbit. So this was quite exciting in 2009 as they repaired things as the space shuttle docked with Hubble, and they put in new instruments and then let Hubble go again back into its orbit. And so one of the things they put in was this new wide field camera 3 that gives us this spectacular panchromatic view, because it can see a bit into the infrared and a bit into ultraviolet light as well as visible light. Now, it's helpful to see things in context. Remember, I told you that Hubble sees things in small fields of view, but then you don't see it in its broader context. So this image shows the broader context. This is a ground-based telescope view of a region near the central region of our galaxy. You see a lot of gas and dust and a whole lot of stars. And then you see things that look like stars, but actually on closer inspection, some of these are clusters of stars, globular clusters. And we're going to zoom in now to one of these globular clusters and transition over to the Hubble image so you can see how this works. So if Shiloh can just... very good. Ready? So there's the constellation we're looking at. We're zooming into that one, what looked like a star, but it's actually a cluster. And now we're going to transition over to the Hubble image where you can actually see the details deep into that cluster. There you go. So context is very important, right? I hope you didn't get sick doing that. All right. All right, I've told you that the universe is beautiful, and I've mentioned this a little already, but the universe is always also active. It's not stagnant. I've mentioned this whole idea of star formation as an example. Even in our own solar system, the planets around our one star, the sun, are very active. One thing you can do when you have good telescopes in operation for long periods of time is compare something over time with images of itself. And so we've watched things like Jupiter over decades now and noticed changes. First of all, you see the beautiful stripes of the different atmospheric areas on Jupiter, but you can also see that giant red spot, which we know is a huge storm, it's bigger than the size of the Earth, it's actually changing in size. It's shrinking over time, and new spots are popping up. So we know that the atmosphere of Jupiter is dynamic. Here's a region that you may recall. It's a famous Hubble image of the Eagle Nebula. Again, these pillars I mentioned that you often see in regions where massive stars have recently formed, and the radiation from them carves out pillars where it leaves behind the denser gas and carves out the less dense gas. Well, we went back to that last year with the Hubble Telescope. Actually, now it'd be the year before last, now in 2016, with the newer camera, and got a bigger field of view here so we could see it in a little more detail. But we also looked at it in infrared light. You see, different kinds of light give us different types of information. In visible light, we see a lot, but we are blocked by the dust. We can't see into these dust clouds. Kind of by definition, they block light. But infrared light can enable you to see into and beyond some of this dusty emission. So here's that same region, invisible light on the left and infrared light on the right. And in infrared image, you can kind of begin to see into some of these pillars. First of all, you see a whole lot more stars in the whole region because you're seeing through this dusty veil. And then you can see some very active regions where some stars that are heating up and becoming protostars and showing up in infrared light are apparent, especially at the tips and sometimes in the middle of these dense columns. Different types of light give us different types of information. In astronomy, we need all different types of telescopes. I think of it like a symphony orchestra. We need infrared telescopes, visible light telescopes, ultraviolet telescopes. We need X-ray telescopes and radio telescopes. We need telescopes in space, telescopes on the ground. We need cameras and spectrographs. We need all kinds of instruments to give us different information, just like different instruments in a symphony orchestra. And you bring all that together and you get a much more complete picture and a much more harmonic sense of the universe. Here's another interesting region. We just released this image in December. It's a jet that's being ejected from a young star, a baby protostar that's forming, buried in this dust cloud. You can't see the baby star in here. But one phase that baby stars go through as they coalesce and material falls in on them is that some of the material will get caught up in the winds of the star and even the magnetic fields around the baby star and get ejected in these bipolar exhaust jets. That's something I also studied in my own research. They're quite spectacular. These jets are a common phase in the formation of a star, and they are moving out sometimes at hundreds of kilometers per second. But we also thought that this double-sided jet looked like a double-bladed lightsaber with all the Star Wars frenzy. So we had a big press conference about how Hubble had discovered a lightsaber in space, and that got a lot of press. All right, here's the Orion Nebula again, a different Hubble image right in the core where you see some of the hottest, brightest stars. But we're going to look very carefully at some of the stars embedded in this region because something interesting was noticed about them with Hubble. And that is when you look carefully about some of these stars, you see these dark silhouetted regions around them. They are disks that in their physical diameter, but they're about the size of our solar system. So this got people thinking. This was first seen in this region with Hubble in the 1990s, and then people began to look more and more and more and realize that disks around young stars are very common, and this must be the region where planets form, right? This is the region of the solar system. We still have leftover dust in our own solar system. The zodiacal light is basically leftover dust that's reflecting light. And in fact, now studying these disks is a very hot topic in astronomy. This is the circumstellar dusty disk of another young star that's recently formed, as observed in great detail with the radio astronomy array known as the Atacama Large Millimeter Array, or ALMA, in South America. You saw a glimpse of this on the film we just saw. It has observed so much detail in a circumstellar disk in millimeter light that you can actually see rings and gaps, which can be seen as evidence of embedded planets forming in this disk around this star. So this is a very hot topic now. How do planets form? Where do they form? Even old stars are active. So this is a beautiful nebula. Again, we call anything fuzzy a nebula. This is an older star losing its outer atmosphere, which is also a common phase that older stars go through as they become unstable, as they start to run out of their inner fuel. And it can be quite beautiful. So this kind of bipolar expulsion of gas looks to many like a butterfly. So it's referred to as the Butterfly Nebula. More massive stars actually become so unstable that they will explode into something we call a supernova. This is the debris of a supernova that went off 1,000 years ago, and it was actually recorded by astronomers, or whatever they were called 1,000 years ago, watching the sky from China and from other places around the world as a sudden brightening in a particular star. And now, even now, with telescopes like Hubble, we can see the debris expanding out from that original explosion. We call this the Crab Nebula. This is beautiful and it's interesting, but it's got another aspect for us to think about, which is we've understood now that stars, as they process their inner hydrogen, they create heavier and heavier elements. They're like little factories. And then when a star explodes like this, it disperses that heavier material into the surrounding environment, and it can get caught up in the next generation of star formation, enriching those stars, and their presumably planets can form around them because of this heavier material. Here's another region. If you look carefully, you see some purplish material dispersed amongst the stars. That's another remnant of a supernova. And if you look at any part of that gas, you could see a green circle there. That's just an example region with a spectrograph. So a spectrograph is not a camera. It instead takes the light and spreads it out like a prism into its constituent colors. A spectroscopist can look at that and see the pattern of colors. And in some colors, you get a lot of light, and in some, nothing. And those patterns tell you what kinds of elements are in that gas. And in this case, we're seeing the patterns of oxygen and carbon. It tells us that the star produced those heavier elements and now is blessing its environment with these heavier elements. We can actually look at very early galaxies and see that most of those stars had not much more than hydrogen, and now in galaxies like our own that have had several generations of stars, we have stars and their environments that have heavier elements that we need for planets and life. So I view stars as God's factories for creating these elements that we need. These clouds, again, and stars fill galaxies, but galaxies themselves can be quite active. And just so you have a sense of where you are, we can't get out of our galaxy, but we've done our best to look around our own galaxy, and we understand that we live in a spiral galaxy that has a dense bulge. Our solar system is a star, about 2/3 of the way out, near the Orion arm of the spiral. And we can look toward the center of the galaxy, or we can look off the plane of the galaxy, or we can look out to the outer edge of the galaxy and see different things. We also look at other galaxies and find interesting phenomena, such as galaxies colliding. Here's two galaxies coming into close proximity of one another, and if they are close enough, their gravity, mutual gravity, will pull these galaxies together. They don't tend to create a lot of star-to-star collisions, but rather what they do is disrupt through the mutual tidal interactions and so forth, the structure of the individual galaxies, and create turbulence. Here's another pair of galaxies that are farther along in that merging process, and you can see how they've lost their individual spiral structures, and the turbulence has incited a lot of new star formation. So that's what those bright regions signal to us, is a burst of star formation in these merging galaxies. Turns out merging is a very important historical part of many galaxies. We think the Milky Way actually is the product of several mergers. And if you think that's all past, you are mistaken, because it turns out we now realize we're on a direct head-on collision course with the Andromeda galaxy, which is our nearest grand spiral neighbor galaxy. Some of you may have seen Andromeda with a telescope. It'll get easier and easier as it gets closer and closer. So probably we will have a very different night sky in about 4 billion years when the two galaxies come together. All right, so stay tuned. Galaxies can even do odd things. The clusters of galaxies are the most massive entities we know of. And as per Einstein, great amounts of mass can actually distort space-time. Well, what does that look like in astronomy? Well, when we look toward a cluster of galaxies, it's actually acting like a lens. So galaxies that are behind the cluster, the light coming through or around that cluster toward us, can get distorted and lensed. So this odd-looking snake-like thing is actually just a normal spiral galaxy, but the light is coming through this foreground cluster of yellow galaxies through the distorted space from that cluster. And by the way, most of the mass is in dark matter that we can't actually see. And it's getting elongated and distorted and magnified. So that's called gravitational lensing. Now, this is quite interesting in its own right, but it's also useful. Astronomers have turned this into a clever tool, because if we can find regions where background distant galaxies have been lensed, if we don't mind the odd distortions, we can study more detail about the composition and makeup of these background galaxies than even the ones in the foreground. We're given the gift of a magnifying glass to see galaxies that are normally too distant for us to be able to see. So astronomers are using lensing now to study very distant galaxies that are magnified, and to also look at their distortions to understand how the matter, and in particular the dark matter, is distributed in that foreground cluster. It's a way of mapping out dark matter, even though we can't see it on its own right. All right, the universe is also enormous in both space and time. You already know that, but let's just kind of think about that pictorially. There's our sample galaxy again, but there are a whole lot of galaxies. In fact, it turns out that we now realize there are hundreds of billions of galaxies in our observable universe. Here's the Hubble Ultra Deep Field. Many of you have seen this, but it's still astonishing to me every time I look at it. This is a small area of the sky looked at with Hubble for several days, so we could collect a lot of light, including light from the faintest objects in the field. And so what you see in this image are thousands of galaxies. Every little blip of light here is not a star, but a galaxy, sometimes with hundreds of billions of stars. There are a few foreground stars, like this one, but almost every other blip of light here is an entire galaxy. If we could look at our Milky Way from a distance like this, it would look like one of these spirals, here or here. So that gives us, I hope, a sense of humility, perhaps holy fear. The universe is enormous. And imagine this extrapolated over the whole sky. And the other piece of this is that these galaxies are at different distances from us. Some are closer, some are farther away. Teasing out those distances is one of the hardest tasks for astronomers, but it's also one of the most interesting, to compare what a more nearby galaxy is made of and looks like compared to the more distant ones. Why? Because it's taken time for the light to get to us. So if you're looking at a very distant galaxy, you're looking at it as it was when that light began its journey. We use light years as a unit of distance. So a light year is the distance that light travels in a year. And we're now seeing galaxies that are billions of light years away. So we're seeing them as they were billions of years ago. Now, we redid this ultra deep field recently using a little bit of ultraviolet and infrared light to get as much information as possible, and re-released it. And that made headlines. Even the front of USA Today in June of 2014 put it right up there on the front cover. Even the Huffington Post, not known to be reverential, said "Holy Hubble" when this came out. And here's an example of astronomers looking at the most distant things. You wouldn't really see anything in this box unless you look carefully, but blown up you can see a kind of reddish blob, and blown up a little bit more it's a bigger blob. Not much to see there, but it's very interesting because it is one of the most distant galaxies that's ever been seen. It's reddened because as the universe expands, light traveling over that expanse of space gets stretched, the wavelengths of light, as through the expansion, the stretching of space. So we see it at a longer reddened wavelength of light. And that little fragmentary galaxy, it hasn't had a chance to merge with other galaxies. It hasn't grown as big through merging. It hasn't had generations of stars. It's very primitive. But it's shining to us from close to the beginning of the universe. So we now think the universe is about 13.8 billion years old, and we're seeing galaxies now that are shining to us from within that first 0.8 of the 13.8 billion year history of the universe. Pretty amazing, huh? In fact, as telescopes like Hubble have been better, I never know which way to turn here, but okay, so this is an example image showing as over time instruments and telescopes have improved, they've gotten more sensitive, so you can see fainter objects. Well, that translates into seeing more distant galaxies sometimes. That's what the arrows are trying to represent. We're seeing fainter and fainter objects, which means seeing, in many cases, more distant galaxies, which translates into seeing back in time, which is what the timeline down here is meant to represent. Off to the right here would be the beginning of the universe, the Big Bang, the first gas, the first stars, and the first galaxies. And we're now able, with our telescopes, to see close to that, within the first few 100 million years of the Big Bang. And we can compare what early galaxies are like to what galaxies are like now. They've had many galaxies in our own epoch have gone through several mergers. They've had several generations of stars. They're enriched with heavier elements. We can compare both the morphology and the composition of galaxies over time and see how the universe has evolved over billions of years of time. A future James Webb Space Telescope will be an infrared telescope that should be able to see even farther back in time. And so what we're discovering by looking at this evolutionary history of the universe is that the universe has developed over time, and it continues to mature and change with the production of stars, heavier elements, and planets, providing the conditions needed for life to thrive, for us to have a planet and life, at least on one planet. All right? That's what we've discovered in astronomy. Does that imply a purpose for this whole ensemble? I have just moved from science, outside of science, to philosophy, all right? So everything I've set up to the purpose arrow is our discovery and our scientific discovery. The inference of purpose is moving outside of science, but it's a very important question. What does it mean that the universe has evolved toward being able to have and support advanced life? So here I'm moving into questions of perspectives of faith. What about the perspective of faith? Can science and religion both address truth, different kinds of truth? These are kinds of things you've been talking about in the seminar here. How does, let's say, a biblical view of the cosmos compare to the scientific view? I think it's helpful to remember, and this is so simple, but so many people get this wrong, both scientists and people of faith, and these are overlapping groups, of course, but science answers a certain type of question really well. How does nature work? How does the physical universe work? What's the natural history of the universe? How do the physical forces of nature work? That's really important. Questions of faith often address bigger questions, capital W, why? Why are we here? How should we live? Is there a God? What does God want from us? Those are bigger types of questions that scientific tools don't help us with too much, although they can inform us. And likewise, the questions of science, the specific questions of science, are not generally well addressed by religious texts when they're specific questions. That probably seems obvious, but there's a lot of nuance to that in public discussions these days, both from the mouths of religious leaders and from the mouths of scientists. All right, here's some perspectives on faith and science, and I have to crane my neck to read these, but Freeman Dyson, a very famous physicist, said, "Why are we here? Does the universe have a purpose? Whence comes our knowledge of good and evil? These mysteries and 100 others like them are beyond the reach of science. They lie on the other side of the border within the jurisdiction of religion." So he has this very sort of separate magisterium kind of view. Not everyone has that bifurcated a view. Francis Collins says, the geneticist says, we cannot discover through science alone the answer to these big questions, capital W, why. Why is there life anyway, and why am I here? Even the National Academy of Sciences said that basically science is a way of knowing about the natural world, but it can't say anything about supernatural, and the question of God is something about which science is neutral. Now, not every scientist actually agrees with that statement, all right? I mean, you've probably heard plenty of scientists who would say, no, science can, in fact, inform us about the absence of the supernatural. And so that's a question in science dialogue. But for the science societies, they've made public statements saying that science addresses only the natural world and does not preclude religious faith, at least in fundamental principles. And then John Polkinghorne, physicist and Anglican priest, said, science and theology are both concerned with the search for truth. In consequence, they complement one another rather than contrast one another. Of course, the two disciplines focus on different dimensions of truth, but they share a common conviction that there is such a thing as truth to be sought. And I think that's a really important point. Both science and theology is a quest for truth with the assumption that there is something called truth that's there to be found. I was musing with one of your colleagues here about why there are so many active religious groups at MIT. MIT has more student active religious groups than any other college in the U.S. Why is that? You could speculate, but it really seems to be that there is a kind of congruence with these different kinds of searches for truth with the idea that there is such a thing as truth. All right, I want to take a little digression here to talk about questions of where science and religious faith and philosophy come together and why a science society would care. So one of my hats is with the American Association for the Advancement of Science. We have this wonderful motto called Advancing Science and Serving Society. Our goal is to advance science, engineering, and innovation throughout the world for the benefit of all people. Well, how do you advance science and serve society if you're not in communication with a large swath of society? Many people in society think about science and hear about science and think about lots of things through the lens of their faith and their faith communities. So it was decided some years back by the AAAS that they wanted to develop a more active dialogue between scientists and religious communities. Hence the DOSER program, which I represent, the Dialogue on Science, Ethics, and Religion, which is an effort not to do the deep theological and philosophical work of thinking about how science and religion relate, but rather to bring scientists and religious communities into better communication about the implications of modern science. So here's an image of a group of folks in one of our projects, which is related to what you're doing here. We have many projects going on, one with journalists. We have public events and programs. We have worked for the last few years bringing religious leaders and scientists together for workshops in various cities. And we now have a funded project called Science in Seminaries, where we are bringing together seminarians and scientists with the goal of helping seminaries that would like to incorporate more science into their core educational programs. This is a group of seminary professors and clergy in one of our planning meetings for this whole project at the Hall of Human Origins at the Museum of Natural History. Some of the questions that bring these things together, and maybe does this thing work? Should I be using this? Okay. In the planet's temperature, I think, yeah. What should we do about that if that's true? How big is the universe? Could there be life on other planets? What's our relationship to this planet? What's the purpose of the universe? What does it mean to be human? What separates us from animals, other animals? What does science tell me about being human? What do religious texts tell me about being human? What do scientists know about human origins? What does neuroscience say about who I am? Is love only a chemical process? Is there such a thing as a science of prayer? Do my thoughts determine my actions, or do my actions determine my thoughts? And can theology and science come to complementary conclusions? Whew, okay, get all that? So there's a rich palette and many, many, many more issues that people have on their minds that can be brought into discussion in churches, in classrooms, in families, where the concerns and interests we have about life as a whole are informed and affected by science and technology. And that's where you come in and where we come in. So just as I announced last night, the culmination of our Science and Seminaries project are these retreats this summer where we want to bring together representatives from our pilot seminaries that have been trying different ways of incorporating science into their core required courses that all future clergy would be taking. And we want to bring in others from other seminaries who can benefit from hearing from some of these lessons learned from our pilot seminaries, and vice versa, can offer their own ideas, kind of cross-fertilize. So these are summer retreats that should be fantastic. You don't have to have experience incorporating science into your courses to come to the retreat, but you do have to demonstrate an interest in why it would be beneficial, you think, in your seminary environment to try to do that and to learn ways of doing that. We as the Science Society provide science resources and tools and connections. The seminaries themselves are thinking of ways of which this would be appropriately integrated into the core courses. And so please check us out. The website is scienceforseminaries.org. And we have 3 retreats this summer that are focused on the 3 ecclesial families of the ATS. The Catholic one is August 2nd through 5th. If you go to scienceforseminaries.org and look under the Events tab, you'll see all about this and how to apply the application process. We can only select a limited number of participants, but if you are selected, then we pay your way, your travel, all your expenses at the retreat, and a stipend as well. So please come and consider participating. You're just the type of audience that we really want to engage in our conversation. I think it's a good parallel effort to what's going on in the effort here with this project. All right, Pope Francis, as you already know, has already said good things about science. He said that the Big Bang and evolution are real and require a creator. I just point you to the second bullet there that he says, when we read about creation in Genesis, we run the risk of imagining that God is a magician with a magic wand, able to do everything. But that is not so, Francis said. He created human beings and let them develop according to the internal laws that he gave to each one so they would reach their fulfillment. So it's very inspiring to have a religious leader talk positively about how seeing human beings as made in the image of God can fit quite nicely with a scientific and anthropological understanding of the development of humanity and life. All right, some questions. Could the universe actually tell us something about the nature of God? We have to be careful here. There are temptations of those to say, wow, with my telescope or my microscope, I've actually seen proof of God, right? And then somebody else says, well, no, actually, we can explain all that without invoking God. So, the whole God of the gaps problem and all that. So without invoking God as an explanatory scientific principle, are there some things, if you're looking through the eyes of faith, that you could philosophically infer by observing the universe? This is not a science question, it's a philosophy question. But here's some ideas that I had when I look at the universe. If you're looking at the universe with a faith perspective, you could infer some of these characteristics of God, if you're already assuming that God is responsible for the universe. That God must be powerful and creative and a lover of beauty, making this connection between the creation and those of us observing it and seeing this concept of beauty. Patience, 13.8 billion years, all right? What does patience mean for God? I don't know. But in our view, why not just snap your fingers? But there's something about patience, even in the development of our own lives, right? There's not a snap of the spiritual finger and we all become spiritually mature in an instant. For some reason, God allows this lifelong maturing and development, just as the universe seems to have been maturing and developing. God is faithful with fundamental physical laws that don't jump around every other minute, but also within that there's a sense of freedom now. We understand now through things like quantum mechanics and even chaos theory that things are not as cut and dried as originally thought in physics. And that God has enabled a universe that is fruitful. There's life in at least one place. And there is life that can actually study and appreciate the universe in which we live. So these are some of the thoughts that I've had. You may think of others. Just mentioning that in Scripture, most often in Scripture, there's not some debate about evolution versus creation. The writers of Scripture hadn't even heard of some of those concepts. But most of the time when nature and the heavens are mentioned, they're mentioned in not as seeing the heavens as gods in and of themselves, but rather as portals of praise. And so the famous psalm here, which I love, is that the heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they're pouring forth speech and knowledge, yet without language per se. They're not heard, and yet their voice is heard throughout the earth. And I think that's true, right? People around the globe and throughout human history have looked at the heavens and gleaned some kind of awe and inspiration from the heavens. It's telling us something. And then in Christian thought, it's even deeper than that the cosmos is actually the home of God who becomes part of the cosmos, who becomes incarnate. The God who actually is upholding the universe became incarnate. Now, you all could say that much better than I. But you get the point here that Christian belief actually personalizes the God who is responsible for the universe in Jesus. All right, but there's some tough questions. All right, what will the long-term future of the universe hold? Right now it looks like the universe is expanding and accelerating in that expansion. And if you just follow that out, it looks like we're just going to, all the stars will eventually burn out and we'll freeze to death. The end. Is that okay? You know, what does that mean? And what about the vastness of the universe? Does that mean that we're just totally insignificant? You know, Carl Sagan, again, who is a great inspiration to me, but he said, who are we? We find that we live on an insignificant planet of a humdrum star, lost in a galaxy, tucked away in some forgotten corner of the universe. That's what a lot of people take away from this. You know, not only have we been quote unquote dethroned from the center of the universe, as we heard from Brother Guy, is such a totally wrong picture of things. But people out there have the sense that the more we discover in the universe, the more insignificant we are. But you don't have to interpret it that way, right? That's a philosophical choice. The psalmist had that same sense of insignificance, and again was looking out at the heavens and said, "O Lord, our sovereign, how majestic is your name in all the earth. When I look at your heavens, the work of your fingers, the moon and the stars that you've established," here's that feeling of insignificance. What are human beings that you're mindful of them, or mortals that you care for them? You know, are we totally insignificant? But it goes on and says, and yet you've made them a little lower than God and crowned them with glory and honor. You've given them dominion over the works of your hands and have put all things under their feet. Now, when I see that, I say, well, wait a minute. The only thing we've been able to have dominion over is the earth, and we haven't done a very good job at that. But I view that also, you can view that as the capability of doing science. We may not be able to visit these other galaxies anytime soon, but the fact that we're able to study and apprehend knowledge is a gift. And I believe that is a sign of our significance in that sense, is this giftedness of our ability to study, to learn, and then you can go on from that also and believe that we are objects of God's love. And that is, to me, real significance. But that's philosophy. You know, you might have your own interpretation. All right, there are more tough questions, though. The universe may be beautiful, but it's also ugly. I mean, why are the processes that are necessary for the creation of planets and life also causing heartache and grief? I mean, it turns out that, for example, plate tectonics on the Earth are really important for recycling our atmosphere and giving life the kinds of things that we need, and yet plate tectonics cause horrible grief with earthquakes and so forth, hurricanes, tornadoes, all kinds of things. How does that fit into a good God's picture of the universe? And what do we do with the fact that we cause each other a lot of pain and suffering, not only humans to humans, but humans to animals? One example I think of is going on right now is this horrific massacre of elephants, gentle, intelligent, sensitive creatures that are now being massacred by the tens of thousands every year by people who come in and shoot them down just for their tusks, and elephants grieve for their loss, and so forth. Is this not evil? I would say it is, but how does that fit into a natural picture of nature? This is something for you theologians to help us think through. There is this idea of the incarnation, that God is participating in both the suffering and the joy of life, and I leave that to you experts to piece that all together. All right, I need to finish up here in just a few moments, but I want to give us a few more examples of where science, hot science, is taking us. And one of the things I encourage in the seminaries that we're working with is to make sure that you're incorporating some of the neat science and troubling science that's going on right now, not the science of 20 years ago. You know, kind of keep up with what's going on, because we're being presented with new ethical questions and new promise and new dilemmas. For example, we're discovering lots of planets outside our solar system now. We're also discovering a lot going on inside our own bodies. You know, we have something like 10 to 100 trillion microbiota within our own bodies, 10 times the number of cells without your DNA inside you of other organisms than of cells with your DNA. Now that number is disputed in various ways, but still the point remains, there's a huge number of organisms living inside of you with their own communities and ecosystems. So what are you? Are you one person, or are you a community walking around? You know, you all depend on each other. What does that mean? It means a lot, practically speaking, for our health care and our diets and our medical care, but it also means something philosophically too, and even theologically, that we talk about humans being distinct from other creatures, but what does that mean? Our body is filled with other creatures. We couldn't live without the other creatures. They couldn't live without us. So what exactly does that mean? And here's another issue, the interface between machine and brain is blurring, all right? As you know from everybody who's staring down at their little devices, but even devices that are implanted inside of us, this is becoming an issue. So now I just bring these up as little examples of how the advance of science and technology is raising new questions that we need to be thinking of. Our genetics, how much do our genetics determine who we are? How much do our brains and neuroscience determine who we are? What does it mean that the whole universe is changing? How do we respond to some of these discoveries? I want to get back to the universe now, but I think one way is that we can give praise, a sense of awe and wonder. We can also turn some of this knowledge, at least Earth-relevant knowledge, into caring for other Earth inhabitants. And I think exploring and learning is something that is good for us as human beings, and also is glorifying to God if you're a person of faith. So I want to point out that in the universe, there are constantly new discoveries, new mysteries, new surprises. What is dark matter? We've now realized that most of the matter out there we don't really know what it is, but we see its gravitational effects, so we're trying to understand it. And now, more recently, the surprise that the whole universe is being pushed apart and accelerated in its expansion. We don't know what's causing that, so we just call it dark energy. It's a mystery. It may be an aspect of gravity that's repulsive that we didn't really understand before. Are there other planets out there like Earth? That's a big quest right now. We don't know yet. Is there life beyond Earth? I don't have time now to go into all these details because I don't want to make us late for dinner, but I'm going to just buzz through these and show that these guys discovered the acceleration of the universe. Now we're trying to figure out what dark energy actually is. Even in our own solar system, we're discovering interesting things. These are evidence of water vapor plumes coming out from under the ice in the moon Europa, indicating that there might in fact be a way of studying the water on Europa without having to dig through the ice and seeing if there's microbial life there. Very exciting. Here's an artist's conception of a real discovery of a planetary system around another star. This whole idea of finding exoplanets, planets outside our solar system, was just science fiction 3 decades ago. And now it's such an ambitious enterprise that we can't even keep up with our discoveries. We're discovering more than 1,000 of these every year now. So now we want to know, here's a collection of stars. If only one star in the 200 billion stars in the Milky Way is our sun, couldn't there be other stars that have planetary systems, and could some of them be like Earth? That's the quest right now. Here's a little graph that shows you from the late 1980s, when we knew of no exoplanets. The count has been growing exponentially. That goes through 2014. If I had 2015 up here, it would be even more. The number of these planets discovered every year is growing by leaps and bounds, all due to the technological advances. Now, the next thing we want to do is build a telescope that can tell us more detail about these planets, looking at their atmospheres. How will we know by looking remotely if they support life? We'll be looking for evidence of oxygen in the atmospheres of these planets, for liquid water, for reflected light, to see if it looks like reflected light from our life blooming Earth, and signs of biological activity. Livestock on Earth produce a lot of methane, so we might find a bovine planet someplace else. So, we're stuck looking at these planets remotely, but how do we find out if they have life while ruling out other explanations for these things? This whole field of astrobiology is a hot topic right now in science. In astronomy, it's bringing together astronomy, biology, chemistry, planetary science, and philosophy and religion. And in fact, the Vatican itself, the Pontifical Academy of Sciences, held a major conference on astrobiology in 2009. I wonder if Brother Guy was at this. Is he here tonight? Were you at this? Were you there too? All right. So now I am not responsible for that cartoon on the right in the Washington Post, but I thought you might be amused by it. It certainly made the press. That article was called "When E.T. Phones the Pope." But here's a quote from Father Funes, who said, "Why is the Vatican involved in astrobiology? Although astrobiology is an emerging field and still a developing subject, the questions of life's origins and whether life exists elsewhere in the universe are very interesting and deserve serious consideration. Those questions offer many philosophical and theological implications." All right? So here we have a very rich field for dialogue. In general, what good is science? Or what good can it foster? Well, for one thing, science and technology can inform us of what we need to do and enable us to serve as stewards of creation and servants of others. All right, so here's an example, an image from the space shuttle looking back at the Earth after servicing the Hubble Telescope and seeing that very thin wisp of a bluish hue of the atmosphere around the Earth as the sun sets behind it gives us a visual sense of the kind of beauty and fragility of our own atmosphere and our own planet. We have the ability to do great good or great harm to our own planet. We need to think of it in that way as stewards. We can use technology and telescopes to look down as well as up. Here's another example of looking down with telescopes and finding, for example, that the Aral Sea over time has grown much smaller. So this is just an example of how we can see environmental changes and do something about it. Here's an example of people in a refugee camp in Africa who were having to leave the camp to look for water, very dangerous, where satellite technology actually identified locations of underground water, and so the people were able to find water in more safe ways, a way of using technology to serve others. There are countless examples, but I just pull these as examples. Science can also bring a sense of wonder, humility, and even inspire worship and praise. It's fully appropriate to bring this into a setting of worship and art and contemplation. Here's a colleague of mine from Goddard Space Flight Center, Gladys Kober. She works with astronomy data, but every summer she goes on a mission trip to an Asian country where she goes to an orphanage, and these are some of the kids who live in the orphanage there. These kids, many of them are children of martyrs. They've had traumatized lives. But fortunately, they have enough food, they have enough clothing. So what does she do? Her ministry is to tell them about astronomy. These kids want to hear about space. It lifts their spirit. They want to be astronauts just like every other kid, right? So, science and the sharing of discovery can be seen as a great gift to uplift the human spirit, and I believe that's very much true. Here's a student who's visually impaired, and we've created tactile images of pictures from space taken with the Hubble Telescope and other telescopes, and coded them with tactile coding such that a galaxy feels different from a star, which feels different from a planet, which feels different from a nebula. And these visually impaired children and adults are loving these images with their fingers. They're seeing the same beauty that we see, and they get the same sense of beauty and wonder and awe. And I can tell you, I spoke to this class. These kids were every bit as excited about seeing the universe with their fingers as we are with our eyes. That's a way of using science to uplift others. Here's an uplifting image from Hubble last year, our 25th anniversary image of a very active star-forming region. And by combining visible light with infrared light, we can see both this massive cluster of recently formed stars and the surrounding gas out of which those stars formed. And there are still young stars shining in here in infrared light that are still in the process of being formed. It's quite a beautiful image, and it shows both the beauty and the activity of our universe that is continuing and that our astronomy will continue to tell us about. Here are some resources I want to leave you with. There are many more I could tell you about, but in particular I want to point out, well, I really like Francis Collins' book, The Language of God. There's a book, Not Just Science, Questions Where Christian Faith and Natural Science Intersect. It's a nice study book. Each chapter is written by a different scientist. I wrote one of the chapters. There's a book of literature called The Book of the Cosmos, Imagining the Universe from Heraclitus to Hawking. And here you have this wonderful collection of literature that brings in both the astronomy, the philosophy, the historical views of cosmology, and even scripture together in one anthology. The American Scientific Affiliation is a network of Christians in science who are scientists or who are science teachers or science enthusiasts. There's a lot of resources on the webpage, and it's a very good organization, www.asa3.org. I encourage you to look up this organization and its website. And of course, the Dialogue on Science, Ethics, and Religion program, which is not a religious program itself, but it's designed through the Science Society to develop dialogue between scientists and religious communities. If you're interested in images from the Hubble Space Telescope, just go to hubblesite.org, and you'll see all the images in this wonderful gallery, and you can download them, and it describes them. It's a wonderful place to go. In closing, I have two closing slides I want to share with you. One is the prayer of Johannes Kepler. And he wrote this toward the end of one of his scientific books, if you will. Now, we're not allowed to write prayers now at the end of our published scientific papers, or at least it's not common. But Kepler did. He'd come up with his tremendously useful deduction of the laws of the heavens. And then he wrote, "If I've been enticed into brashness by the wonderful beauty of thy works," this is a prayer, "or if I've loved my own glory among men while advancing in the work destined for thy glory, gently and mercifully pardon me, and finally deign graciously to cause that these demonstrations may lead to thy glory and to the salvation of souls, and nowhere be an obstacle to that. Amen." Can you imagine this being at the end of published science papers today? And yet that was his sense, is that by investigating the universe, it should bring glory to God and actually draw people to a relationship with God. Isn't that amazing? So this is where people like you can be that ambassador, taking the science, but showing people how it can bless them in many ways. I've given this talk, or talks like this, to many different groups. And one group was a collection of doctors, women in medicine and dentistry. And they were very interested in the beauty of the images and the science. And one of the doctors, Dr. Clydette Powell, this was a conference, so they all went back to their rooms for the evening. And then she came to me the next day, and she was so inspired by some of these images that she wrote this down. She scribbled this down, and I read this, and I said, "Dr. Powell, this is incredibly beautiful. Is it all right if I show this in other presentations?" And she said, "Sure." So this is her paraphrase of the 23rd Psalm. You know, "The Lord is my shepherd, I shall not want." She paraphrased it this way: "The Lord is my galaxy maker, I shall not want for praise. He makes me lie down in green pastures and upwards look. He leads my gaze to behold his heavenly glory, and thereby he restores my soul. He leads me in colored paths of awe and wonder for his name's sake. Yea, though I walk through the valley of the shadow of death, I will fear no evil, For he is with me. His nebulae and star clusters and even their interstellar gas comfort me with assurance of his power and majesty. He prepares a tapestry of stars before me in the presence of my enemies. He anoints my mind with the joy of speechless discovery. My eyes overflow with tears. Surely hallelujahs and praise shall fill all the days of my life, and I will dwell in his celestial house forever. Isn't that beautiful? So, let's give thanks and praise for the universe and praise for the gifts of curiosity and science that allow us to explore and understand the wonders of creation. Thank you very much.